We're going to look at finding rational zeros today. Here's an equation that I've given you, and I've gone ahead and told you that the zeros of this equation are -3/2, -5/4, and 7/8. Now, one thing that you might notice is that the numerators are all factors of our constant term of 105. The denominators are all factors of our leading coefficient, 64. This relationship can be used to find a list of possible zeros. Now, this list doesn't guarantee that everything on the list is going to be 0. You still have to check using synthetic division or substitution to find the actual zeros. But what this does is it gives us a starting point. It gives us a list of possibilities to try. So you're going to need your flip books. Go over to the 4 or more terms column and go down to the rational zero theorem. And what you need to write in there is that if a polynomial has integer coefficients, then every rational zero has the following form. And we write it as P over Q. And what you need to realize is that P will always be a factor of the constant term, and Q will always be a factor of our leading coefficient. So make sure you have that in your flip book. Alright, so here's the first example we're going to do. Find all possible rational zeros of f of x, then use the list to find all the zeros of f of x. So the first thing we need to do is find the list of possible ones. Now, as I look at this, my leading coefficient is 1, and my constant term is that -12. Well, factors of -12. I could have positive or -1, positive -2, positive and -3, positive and -4, positive -6, and positive and -12. The nice thing, my factors of my leading coefficient of 1 are only positive and -1. So now I need to use the formula that we had on this last page right here, where it says to get my list, I take my factors of the constant and I put them over the factors of my leading coefficient. I've got to do that P over Q. So I'm going to take each one of these factors, 1, 2, 3, 4, 6, and 12, and I'm going to put it over each one of the factors of my denominator. When I do that, I'm going to end up with plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, and plus or minus 12 over 1. Now, if I had another factor of my leading coefficient, let's say I had a 2, I would continue on with my list. I would put 1 over 2, and 2 over 2, and 3 over 2, and 4 over 2. But for this case, I only have the one factor. Now I can go back through and I can start trying any of these factors. Nope, sorry, they're not factors. I can try any of these numbers to check if they're zeros. So this would be my list of possible zeros. The second part says use the list to find all the zeros of f of x. Now we have two different options for finding the zeros. You can use synthetic division, and if you get a remainder of 0 when you do the synthetic division, then you've got one. Or you can do direct substitution, and if you get 0 when you do direct substitution, then you've found one. So on the next slide, I'm going to show you each way how to do this. So here's our function we're working with. The first one I'm going to do synthetic division. So I'm going to set up my synthetic division. I'm going to copy down my coefficients. Make sure you take note if you need to fill in any zeros. And then I'm just going to guess. From this list, I am going to randomly pick positive 1 to try. So then I come over here and I'm going to try positive 1 out in front. I go through the synthetic division, and if I end up getting a remainder of 0, That means I have found one. Okay, now notice I did not get a remainder of 0. So what that tells me is that positive 1 does not work. So now I can set up another synthetic division problem. Bring my leading coefficients down again. And now I can pick a new one. So I'm going to try negative 1. And I would repeat the process again. Okay, now notice this time I got a 0, which tells me that this negative 1 I picked out in front is a 0. Now, you can continue guessing and checking from here, but that is going to take a while. What you would rather do is you want to take these new numbers here and write that new polynomial that results from doing this division. So we would have 1x squared plus 1x minus 12. And then from here, you would want to try to either factor it or use the quadratic formula or complete the square to find your zeros. I'm going to go ahead and just factor this. The minus sign tells me that my signs are different, and my factors of 12 are 1 and 12, 2 and 6, 3 and 4. It's going to turn out to be plus 4 minus 3. So now, to turn my factors into zeros, I set each one equal to 0, and I solve. So for this particular problem, I got zeros of negative 1, negative 4, and 3. Now I could have also done this using direct substitution. I'm going to go ahead and use the negative 1 right away, since I know that it does work. I could have gone up and plugged negative 1 into my equation. So I would have had negative 1 cubed plus 2 times negative 1 squared minus 11 times negative 1 minus 12. When I go through and simplify that, I would have gotten negative 1 plus 2 plus 11 minus 12, and that is going to give me 0. So either way, you would have been able to find out that negative 1 was a 0. If you use direct substitution, once you find that number that works, that negative 1, you still would need to go over and then do the synthetic division for it so you could get this easier equation. So either way works for finding the zeros, but you're still going to have to go back to the synthetic division eventually to finish finding the other zeros. So once you get that 0, use the synthetic division, get the equation smaller, and then factor it using any method. Alright, so here's another one. Our list of possibilities can get very long very, very quickly. And my constant here is 12, so I would have for my factors of 12 plus or minus 1, plus or minus 2, plus or minus 3, plus minus 4, plus or minus 6, and plus or minus 12. Now notice my leading coefficient for this one is 10. Well, my factors of 10 are plus or minus 1, plus minus 2, plus minus 5, and plus minus 10. Oh, I can't make a 10 today. Now, when I go to do my list of possibilities, I would have, there we go. I would have to do plus or minus 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. So that took care of all of my factors of 12 over the 1. Then I would have to do them over 2. So I would have to do plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, plus or minus 4 over 2, plus or minus 6 over 2, 12 over 2. Okay, that would take care of all of my factors of 12 over the 2. I would have to do that same thing with the 5. So as you can see, your list gets really long really fast. Well, an alternative to that, because once you get that huge list, you have no idea where to even begin guessing and checking. So what we could do instead is we could sketch a graph to help narrow that list down. And what that would do is that would give me a rough idea of where my zeros are. Now remember, zeros are these points where they cross the x-axis. So from that list, I know I would not pick anything above 2 because my graph does not cross up here above 2. I also wouldn't pick anything below 2.5 or so because my graph doesn't cross down here. I would try to guess for these numbers. Now it's still going to take you a little bit of time, but I know that I have a 0 somewhere between the number 0 and 1. So I could guess a half, I could guess the 2/5, or anything from that list that's between 0 and 1. This one, I would probably guess -1.5 because it looks like it falls about there. So a graph can help you narrow down your list. Okay, here's going to be our first practice problem. So go ahead and pause the video, see if you can list all the possible rational zeros, and then find all the zeros. Alright, your list of possibilities, you should have had plus or minus 1 over 1, plus or minus 1 over 3, plus or minus 2 over 1, and plus or minus 2 over 3. From there, I chose to do the synthetic division, and I guessed -2. Did my synthetic division, and I got a 0, so I knew that -2 was a 0. Now, excuse me, I rewrote my equation, so I would have had 3x cubed plus 5x squared plus x minus 1. Now when I look at this, grouping wasn't going to work. I can't use the quadratic formula because it's of degree 3. That means I have to do synthetic division again because I don't know how to factor this one. So I'm going to have to do synthetic division, and I'm going to have to guess and check again. So I set up a second synthetic division problem using my new easier equation, and I guessed -1. When I do my synthetic division, I got a remainder of 0, so I knew that -1 also was a 0. Once I did my second synthetic division problem, I wrote my easier equation again was 3x squared plus 2x minus 1. And from there, I could now factor this or use the quadratic formula or something like that. So I factored it into 3x minus 1 into x plus 1. And then I took my factors, set each of them equal to 0, and found 2 more zeros. Now we ended up with 4 total zeros here. We had our -2 from the very first one, we had -1 from the second synthetic division problem, and then I had 1/3 and -1 again. So notice I have all 4 of my zeros listed here. Since -1 happened twice, you don't actually have to write it down twice because it was a double 0, but if you want to write it down twice, that's okay. Okay, see if you can do this one. List all the possible rational zeros and then use the list to find all the zeros.